So today, what we are going to speak about is about actually what is an infrastructure as a code. Then how do we do infrastructure as a code? What are the tools which will help us to do IAC, and how do we, what are the particular features are available on that tool? So today we'll talk about more on Terraform, and then we'll see. How Terraform is designed or how it works, and then we'll see some demos and how to install a Terraform, how to integrate the Terraform with other some providers, and then see how Terraform works with some demos and all that. Okay, so that's the agenda for us today, and yeah, let's carry on. So just a point. So once we go through all these presentations and the demos, at last we'll have a QA sessions, and you are open to ask any questions in that session. Okay, so let's utilize the best utilize this time to understand what is infrastructure as code and what is a Terraform and all that, right? So so basically, if you see the infrastructure wise, right? If you go back even 5 years or 10 years back, so if you need to create an environment, let's say development environment or a QA environment or your UAT environment or a staging environment or production environment, what we do, we go manually go and create certain steps, or we call it a runbook. We go and do that, execute that runbook, and then for production we have a different set of runbook. For development we have a different set of runbooks, and every time we have to change it. We have to go that file, we have to change it, test it, and everything. And that is one of the reason that our different environments doesn't have the same specification, or specifications are not defined or properly written anywhere. So that's the biggest challenge of your infrastructure management priorly, right? But what infrastructure as a code does, what we used to do it earlier by manually, now we'll write that manual steps in a certain script, okay, or a certain instructions, and we'll take that instructions and we'll go and execute, right? And then the same code, same environment, if I want to reproduce again, right, then you will have a consistency on your environment. If I'll not have an infrastructure as a code, if I don't have, then you won't get that consistency. Maybe today if you have created a dev environment and tomorrow I need to destroy that dev environment again, I need to create it manually. You might forget certain steps. As a result, you might not have the exact environment that you were looking at, right? So that's where your infrastructure as a code helps you. So that's what I said. I have written, if you look at infrastructure as a code, manages and provision your infrastructure through your code. Okay. So you will provision and manage your infrastructure. You can set up even certain stuff through your code. And basically this ISC, it creates a certain config file, and in that config file you define what kind of environment you need, how many VMs you need, how much CPU you need, how much memory you need, what's your network you need, what's your storage that you need, right? And that's what you can do it through your infrastructure as a code through a config file. So another advantage of infrastructure as a code is if I write my code, right, and if I put my code in a version system, yeah, or I make it a versioning. Let's say tomorrow, if I have made a infrastructure as a code in a file, and then tomorrow somebody else from my team comes in and change it, okay, then I know what are the changes has been happened, and I can version it, so that I can go back and see it. Okay, 1 year back, how was my infrastructure? Now, what is my infrastructure? I can compare these two files, right? By looking at my version history, and then I can identify what are the changes I have made it, right? So all this history that you will have, and then so basically your infrastructure can be divided into multiple modular components. Let's say if you guys are bit aware of let's say AWS. So right, AWS, you have an EC2 instance, you have a storage, you have a S3, you have a VPC, you have a security group and all that, right? So what I do, let's say for one of my customer, I just want to create a VPC and EC2 instance. So VPC will be one of the model, EC2 instance will be one of my model. Now with combining with these two modules, I'll create certain infrastructure. But for let's say for certain other customers, I need VPC, I need security group, and I need only S3. I don't need, let's say, EC2 instance. For them, I'll create by combination of S3, a combination of security group and VPC, right? So if you can modularize this one, right? So you can take any of these modules, any combination of this module, and you can create an infrastructure. So basically, it is very much into modular way you can even design it, right? And to the last point, if you look at codifying infrastructure gives a template to follow for provisioning. So let's say you can create in a template also. I'll give an example. Let's say in our organization, you want to create certain types of EC2 instance, right? Let's say if somebody asks you to create an EC2 instance, the standard template will be, we'll have a T2 micro, you'll have this much of storage, this much network and all that, right? So basically you can create a template and you can store that template. So anybody on your organization wants to create any EC2 instance, you can provide that template and they can just go and utilize that template and create it. They don't need to, define what will be your specifications of your VM, right? You already have defined your VM specification through a template, right? So that also you can do as an infrastructure as a code. So somebody can take your template and then on top of that template, they can customize, but that is a basic template, right? Basic standard that you can define it. So that is basically your infrastructure as a code. So now what are the types of infrastructure as a code? So if I write the infrastructure as a code, there are two types actually. So one is basically your declarative, another is your imperative, right? So what is a declarative one? So basically declarative is nothing but, so when you define your ISC through a declarative, you define what is your state of your systems. So when I say state, that means, let's say I need two VMs of RAM size of 4 GB and storage, let's say 1 terabyte. So this is my state of my system, right? So two VMs having this specification, that is my state of my infrastructure, right? So in this declarative one, so in your declarative file, some configuration file, you are storing this statement or storing these specs, right? So next time if you want to change from 2 VMs to 3 VMs, right? So this ISC will identify, previously I had only 2 VMs, now the customer or the user wants 3. So it knows that already there are 2 will be there on either it's your inner data center or on the cloud area. Previously it is 2, now I have to make it 3. So it will go and create another 1. It won't go and create a 3, right? It will go and find the difference and it will do that, right? And to do it, it needs to go to the cloud or needs to go to the data center to identify this delta. At the end of the day, it will go to the cloud or the data center to create it. But to take that instruction, it knows priorly that what the instruction I need to go and execute, right? That is a declarative one. What's the imperative one? Imperative is nothing but when you define your instructions, right? Let's previously 2, now I have a 3. So it won't check, actually, it won't store your states, right? Locally, it won't store your state. What it has to do, so let's say now I have defined 3 VM, it will go to your cloud or data center. Currently, it will identify, it will execute certain commands to find how many VMs now currently I have. So that it has to execute a certain command and a certain order, right? And then it will find, okay, now I have only 2 VMs, okay, but the desired state is 3 VMs, right? Again, it will trigger another command to create another one. Basically, it's client server communication. So if you are familiar with the client server architecture, basically every time client needs to go to the server, identify what is the information lying there, get that information and find it, compare it, then go and execute it. But in case of declarative, it's not, it's basically the client stores what the information has been created inside the server as in a cache kind of stuff. It's not exactly cache, but it's a kind of that, right? It's stored on the client side, and the client, because the client itself decide what my state will be. So on the client side, it will identify what are the executions or what are the instructions that I need to execute on the server side. So that is a difference. So mostly in the industry, we execute declarative type of declarative approach for my ISA. Okay, so we'll go through a bit of more of declarative when we go to Terraform side. Okay, so this is basically your types of ISA, right? So so what are the benefits? Why I should go and write in the code, right? My infrastructure as a code. So previously I used to do it through manually. So why I need to do it through as a code? Basically, it will reduce your cost, because every time you go and write it, go and manually do it, okay, it has a cost. And cost in the sense, it's not only about INR or dollar. It's about human, expenditure that you are doing it, right? How much of man hour or woman hour that you are doing or spending it, right? That's a cost, right? So if you have written a code which will create your environment on one single clay, okay, that will definitely reduce your cost, right? So that is one aspect, is the cost reduction. Secondly, it will increase the speed of deployment, right? Let's say every time I have to go and create an environment, let's say if you are doing in a continuous testing. So in the CI/CD world, we have a continuous testing. For continuous testing, you also need to create an environment for that continuous testing, let's say, right? So in your SDLC process, right, you can define, or in your pipeline, you can define, okay, at the time of before the deployment, I'll execute this Terraform script or any other, provisioning language provisioning tool. Okay, I'll utilize that tool. I'll first create my environment. Okay, then I'll deploy. Okay, on the script on your script way. Then it will actually reduce a lot of time for your deployment, right? So basically, it will increase the speed of your deployment, because previously I have to go and create my environment and then only I can go deployment. But here, your environment will be created based on certain conditions, and that will be created by your ISA. ISA will go and create it, right? So your speed of deployment will be faster and reduce errors. Manual, always you might miss certain steps, okay? But when you have a code is available, so errors also getting reduced a lot. Then consistency, I was talking about the consistency, right? If I have the same dev environment, I have to create multiple times. Let's say I have 3 cloud infrastructure, right? One is Azure, one is Google, one is, let's say, AWS. And I have to create an infrastructure on the 3 places, right? I might forget different steps and I might not have the same infrastructure as I wanted, right? Every time I create, I might miss it, but that won't happen. So you'll have a consistency on your infrastructure. Then eliminate configuration drift, right? So let's say I have 3 different data centers, right? If I have the same script, which I'll be running on 3 different data centers, then I will not have a drift in my configuration. It's the same configuration which will go to 3 different data centers, right? So configuration wise also will not have any change. So that those are the advantage of your infrastructure as a code. So now, what is a Terraform? So basically, Terraform is nothing but a implementation of your infrastructure as a code, right? So infrastructure as a code is a concept, and the tool which implements that concept is a Terraform. Terraform ideally it's a provisioning tool. It provisions the infrastructure for you, okay? And as I said, So Terraform basically is an IAC tool which codifies the infrastructure. The infrastructure that you define, it writes on the code. And then what it does, it composes, collaborate, reuse, and provision the infrastructure across the IT operations. It composes your infrastructure, it collaborate different types of infrastructure, it reuse, then it provision. Okay. So reuse and all that we'll see it going forward. So reuse will happen when you have a modular structure and all that, you will reuse that one. And then the biggest advantage is this Terraform can be integrated with your CI/CD tool, right? Let's say I am utilizing Jenkins or GitLab or GitHub Action or Bamboo. So these tools, if I'm utilizing CI for my CI/CD, in my CI/CD pipeline, I can integrate Terraform and it will do whatever you want to do. Let's say you want to provision before you want to deploy it, right? Certain environments. So it will go and first deploy and then first go and in provision your infrastructure and then deploy it. So it can easily integrated in your SDLC process, which is nothing but CI/CD tools. Then one of the aspect of it uses a particular language. It's not a programming language. It's a basically declarative syntax it uses, and that declarative syntax is called HashiCorp configuration language. Okay, so you might be knowing the Terraform from the organization called HashiCorp. Okay, so that's why HashiCorp has its own language called HashiCorp configuration language. Basically, it's not a language called C, C++, or Java, Go, and all that. It's or Python. It's not like that. It has a syntaxes. Syntaxes in the sense it's a kind of instructions. You know, I'll show you certain HashiCorp configuration language SCL. So I'll show you while we're doing the demo. So next is your Terraform. Actually, the Terraform tool itself built on the Go language. Okay, internal of Terraform works on the Go language, which you don't need to worry about it because you are not going to write the Go language or you are not going to change the way Terraform works. What you need to work on, you need to create your Terraform configurations files and you need to execute those configuration files so that you can provision your infrastructure. Okay, so that is basically what is in a Terraform and what it does. Next slide. So where we'll utilize this Terraform, right? So where are the use cases? So one of the use cases, if you look at infrastructure as code, that's a very basic use case. If you want to build your infrastructure as code, you can do it. If you want to do multi-cloud deployment, right? So infrastructure, I mean, this Terraform also will be useful. Let's say I have AWS, I have Azure, I have a GCP. So there also I will utilize it. Kubernetes management, right? Kubernetes management in the sense how many nodes, how many slave nodes that he wants to create, how many worker nodes that he wants to create, how to configure worker nodes, pod configuration, everything that you can do it through a Terraform. Okay, because Kubernetes is also one of the provider for your Terraform. Then your network infrastructure is not only about your infrastructure. Infrastructure is not only about your compute, right? It's not computing in the sense it's not only VMs, right? Or storage. It's also about a network as well. So it can also manage your network infrastructure. So as I said, manage your virtual machine images. So virtual machine images. So in AWS, you might have heard of AMI, right? So different type of images. You can also create certain images by using Terraform and Packer. Packer also comes from HashiCorp. So Packer is basically it's a tool which customizes your OS operating system, right? Let's say in the operating system, when you start your operating system, if you want certain software needs to be by default installed, right? That you can do through Packer. Actually, Packer is a tool which customizes your operating system. So you can do that, your virtual machine images by using Terraform and Packer. Then integrate with the existing workflow, which I told in the CI/CD, with the existing workflows like Jenkins, GitLab, Bamboo, and all that. You can do it. Policy as a code. So basically, it happens, this policy actually normally we define in the cloud infrastructure. So in the cloud, let's say in AWS, I wants to create any VM, but I need to make sure each and every VM has a tag, and the tag has to have a name, server name, environment, those. So that is a kind of a policy, right? So I mean, a very simple policy, but there is a policy. So you can actually enforce in a policy, okay, by using a Terraform, and then inject secrets into Terraform. Basically, secrets in the sense that Terraform, let's say you want to access a certain S3, and there you need a secret, right? So how do I utilize that secret? So Terraform also helps you inject secrets inside it by, I mean, by using your vault. So even vault is a secret management tool from HashiCorp. So basically you store your secret inside the vault, and Terraform can pull your secrets from the vault, and it will attach to your Terraform configuration file, and then you can utilize that secrets to create anything on your cloud or your inner data center. Okay, so these are the use cases for your Terraform. Then what's an architecture, right? So if you look at architecture wise, it's not that complex. So you have a user, being a user, I want to utilize Terraform. Basically, I'll install Terraform and all that in my system. And then what I'll do, I'll go and create a Terraform configuration file, which we call it a TF file. Okay, Terraform file. Okay, in that file, Terraform file, I'll write my whatever the configuration or the provisioning stuff that I want to do, and then I'll tell Terraform, okay, go and execute this one. Okay, there are certain commands which we will do at the time of demo. So you tell that Terraform, or you give the instruction to Terraform, okay, now Terraform, you take my TF file and execute it, right? Terraform first, what it does, it goes to the step, because we are doing in a declarative one. So Terraform will have a state file. We call it a state file, that is TF state file. So it will go and look at what is the past state, what is the current state, so not past, what is the current state, and compares with your TF file. If your state and TF file is same, it doesn't do any action. Basically, it doesn't go to the server, do any action. What is the point, right? When you know I need only 2 VMs and I already have a 2 VM, why need to go to server and try to create a 2 new VMs? Because I already have a 2 VMs, right? So it looks at your state file, okay, TF state file. If there is a delta, then it goes and take care of that one. Okay, so it validate with the TF file, with the TF state file. If there is a delta, then it will go and execute, and then it will execute on either any of the cloud infrastructure that you have. You might have an AWS, might have Azure, you might have a GCP, you might have a digital version, Alibaba, and whatever it is, right? That's in the cloud. Even on prem data center, if you have a certain vSphere or anything as such, right, which has an API through which you can access, right? Even there also you can do it. Okay, or you have a OpenStack also, if you have, right? OpenStack actually, Terraform can integrate with the OpenStack. So if you have OpenStack available, your internal data center also can be utilized for a provisioning part. Okay, so this is very high level overview of your Terraform architecture. Okay, so next what we will do, we'll go to the very basic demo. Okay, I'll show you the demo of how do I install my Terraform. Okay, so let me connect to one of my VMs. Okay, so I'll come back to this PPT once we install our Terraform. Okay, so this is one of my VM. Okay, I have connected to one of VM that I have. Okay, so what I'll do now, if you look at, I don't have anything called Terraform, or if I do Terraform version, I don't have anything, right? So how do I install a Terraform? There are multiple ways actually you can utilize install Terraform. One way So it depends on, this is an Ubuntu system. Okay. So I can show it which version of. Okay. Okay. So this is Ubuntu 22 version. Okay. So so we'll, by using apt, I mean, which is a package manager for Ubuntu, through that also you can install your Terraform. Okay. Otherwise, you can download actually your Terraform, and you can install it as well. Okay. Now let's go and download my Terraform. Okay. So download the Terraform. You can actually go back to the Terraform site itself. Okay. And then you can download what is the version, and then you can utilize that version. Okay. So let me show you one way, which is the actually very standard way of. So this is basically, I'm just trying to show you which version of Ubuntu that I'm using it, 22.04. Okay. Now let's say I want to download a certain version of Terraform. Okay. So if you look at what this command does, it goes to Terraform's actually Hasikar has an API. This is API, github.com repos. You go to here and it will provide you the latest Terraform that they have. Okay. And it will go and download what is the version of that Terraform. Okay. So if I enter it, and then if I do an echo of Terraform, right? So it's a 1.4.2. Okay. So I could able to get 1.4.2 version of Terraform, and let me install that one. Right. So what I do, I need to download now that 1.4.2 version of Terraform. Right. So what I'll do, you can see it. I have given the Terraform version 1.4.2 here, and this is the location, right? Now it will go and download it here. If you look at, I have downloaded this Terraform version. Okay. Now what I need to do, I need to unzip this Terraform, right? So what I'll do, unzip my Terraform. Okay. So now you can see there is a Terraform executor is installed inside it. What I need to do, I just need to move this Terraform executor to my user local bin, right? So that every time you come here, you should have this executor on your class path, right? Now, if I do Terraform version, okay, now you can see I have a Terraform called Terraform 1.4.2. Okay, so you have basically you have installed Terraform. This is the very standard way of installing. You can also install through apt-get and all that, but that is not needed because that way you cannot control your version. So here basically you can download this version, and you can also download other version and all that. But if you do an apt-get, you only get what is the version comes with that package manager, right? Or that library, that repository, right? So this is what how you just need to install Terraform. Okay, and Terraform can be installed on any of the operating systems. You can install on a Mac, you can install on Ubuntu, you can install on CentOS, RHEL, Windows, everywhere you can install it. Okay, so let's go back to the PPT itself. Okay, yeah. So installation, we have seen it. Now look at what are the providers. Okay. So what are the different providers available for a Terraform? So what is a provider basically? Okay. So let's see what is a provider. So it says providers are a logical abstraction of an upstream API. That means if I want to use AWS provisioning, right? Then in between AWS and Terraform, there must be a provider or an SDK or a standard library which needs to be present so that I can, from Terraform, I can communicate to my AWS or to my cloud, any of the cloud, right? So there must be certain providers or libraries or APIs should be available. So those libraries, APIs, whatever you call it, those are called providers. Okay. So basically, you can have in Terraform has an integration with any of the providers in the world, right? So it has around more than 2,900 providers. Even you can write your own provider and you can publish it. And if Terraform approves or HashiCorp approves those providers, then it will be listed on the site. So many people have written their own providers and given to HashiCorp, which is listed. That's how it became a 2,900 something. Initially, it was AWS, Azure, GCP. Okay. Later on, all this Kubernetes, Alibaba, OCI, Oracle Cloud, Linode, and all that stuff came in. Okay. So so these are called providers. So now one see how I will integrate, okay, how I will integrate AWS with my Terraform, right? Let's say to provision anything on the AWS. Now, what are the basic things I need? I need to have integration between my Terraform and AWS, right? Then only I can go and create any VM or VPC or security group, whatever S3 storage, whatever service that you want, right? You want to create an AWS, then you need to have an integration. Okay, let's see that demo. How can I create integration between my Terraform with an AWS, right? So let me go to my again here. So if I'll clear it, and then what I'll do first, when you want to integrate on your either Windows or Linux or a Mac, any system, you need to install a AWS CLI. Okay, AWS CLI has two versions. One is 1, another is 2, and 2 is the latest version. So basically, you need to download AWS CLI version. Okay, that is called AWS CLI v2. Okay, so let me download that one, and it's a very simple URL that AWS provides, which is nothing but curl. If you look at, so I am trying to download this AWS CLI exe, this one, and I'm storing and keeping this name as AWS CLI v2. I'm not storing as this name. Okay, I'm storing as this name. So it now downloaded. So you can see I have a zip file called this one, right? So now let me unzip this one. Unzip AWS. Now it's bit unzip. You can. So I got a folder called let's see what is there in. So you have a distribution file, readme file, there's licenses, then there is a file called install, right? So till now I don't have any command called AWS, right? So AWS still not installed, right? I've just extracted. So now I need to install this one, right? So let me see which path I am, and I'm in root, and then I need to install AWS install, and where I need to install. Okay, so basically what is my installation location, and where will be my binary location that I need to give. Let's say my installation location is user local, and then let's say AWS CLI. Okay, I think I missed this one. AWS CLI, and where is my binary location? My binary location will be, let's say, user local bin. Mostly all the binary getting stored there, right? So let's see. Yep. So it got installed. Let me see what is my AWS version. Yes, you can see my AWS CLI is 2.11.3, and it uses a Python 3.11.2, and it has certain Linux kernel that it uses, and then this is the Ubuntu, your architecture, CPU architecture, and that's all. So basically, you now have AWS setup, but you didn't integrate with the AWS, right? So now I have a CLI installed. Now to integrate with AWS, what I need? I need an AWS account, right? So you basically need to go and create an account in AWS. Okay, then only you can have a communication with them, right? So for that, you need to go and create an account in AWS. So I think it's a aws.console.com like that, I guess. And there you go and first you create an account, then I'll tell you what are the things that you need to do it, right? First, what I do, once you create an account, there are few things which you need to do. That is AWS configure. You need to do AWS configure, okay? And you need to create a profile. I'll tell you why I am creating a default, not creating a default profile, but I'm creating a profile. Let's say I'm creating a profile called Terraform. Okay, my profile name is Terraform. What it will do, it will ask you a access key. So when you go and create a account in AWS, basically there also you can create an access key. Okay, you can create an access key and you can create a secret for it. Why we need an access and secret? Because you to programmatically to access it in AWS your account, because when you normally open an account, it will ask you username and password, right? And then only you can log in, and with even MFA and all that you can do it, your mobile authentication and all that you can do it. But here, okay, we are not doing manually authentication, right? We are doing programmatic authentication. For programmatic authentication, what we need to what what we can do is for programmatic authentication, we need to create a secret and access key. Basically, access key has a secret. Is an access key is an username and secret is a password. And with your free account, you can also do it. So there's nothing. Right? So I have my own access key and secret. Please don't miss. I mean, I will just for showing to show you. I am just utilizing it, but don't misutilize this access and secret key. Okay, so now it will ask me the secret. Okay, so I'm just giving a secret. It will default region, so I will give US East 1, which is a standard region. Then output, you can give the output as JSON. Yes, so then your setup has been done. So now I have created a profile called Terraform. Once you created a profile, basically AWS configure, it will create a directory called .aws here. Okay, automatically it will create. So now let me go to the directory. You can see that two files will be created. One is config file, one is credential file. So if I'll do config, so you can see configuration has this configuration. I have a region, I have a output. Okay, output format which I have given a JSON, and I have given this region, and you can see this is my profile. If I do credentials, you can see again my access key and my token. Okay, secret and access key. This is what I have created. Now, so basically your AWS configure has a few commands, okay, which you can also experiment. AWS configure, if you want to see what are my profiles are available, okay, what are my profiles, sorry, profile, what happened? AWS configure list. Profiles. AWS command subcommand. configure list. Yes, it will show you. Okay, I forgot. That's my bad. List profile, let's say Terraform, right? Yes, it will show you my Terraform profile. What are the details? Okay, it will show you that one. And actually another, sorry, there is AWS configure. Then what are the profiles actually there? I can see also there. So you have one profile, that is Terraform. You can actually define multiple profiles, multiple account. If you have, you can actually see it. Okay. So AWS configure list of profile that you can see. So basically, this is how you configure your AWS with this one. I think if you know all these AWS commands and all that, AWS S3 list and all that, I didn't exactly have in my, yes. So I have to do all this, do a bit of configuration again for this one. So basically, if you know certain services which is available, you can also identify all those stuff. Okay, what is there in S3 and all that, but that's not the point of discussion here. Now I have configured AWS with my own system, right? So let's go to the presentation. Let's see what is still available. So AWS integration we did. Now we'll have an infrastructure as a code and execution. How do I create a IAC, or I can create a Terraform configuration, and how do I execute that one, right? So let's go to this one, my, yes, my command line, and let's, what you need to do, if you look at here, I'm a root, I don't have a folder. Let me create a folder. Let's say folder name is Terraform. Let's say I create a folder in Terraform. Sorry. I'm in Terraform, so nothing is there. So what I'll do, I'll create a configuration file. Okay, so it is main dot. So any Terraform configuration file is called extension is .tf. Okay, so in TF file, there are few things that I need to write, which I'll tell about here. Okay, when you provision certain stuff, first thing that you need to you need to write is who is your provider. It's a AWS, or it's a GCP, or it's a Azure, or it's a Kubernetes, or it's a console, or whatever it is, right? So so we need to first write that one. So first thing that we have to write is who is my provider. Okay, so my provider is AWS one. Okay, and then I will write it here. Who is my provider? Let's say AWS is my provider, and what is the profile for it? So if you remember, we have created a profile called Terraform. I'll just give a profile Terraform, because see, I can also write here what's my secret, what token, everything, what's my region, my output, all that I can write it here. But if I write it here, then you are exposing your credential to outside side, right? Basically, I have stored my credential in a dot or a hidden file, then I am importing from there. Okay, so hence my profile, which is a Terraform profile, I have just imported. I have given the credentials, so that it will go and connect to my AWS provider. Okay, so this is all about my provider details, which I have put it here. Okay, so next thing is, now I have to create certain resources. So here let's take the example of, I need to create a resource called, let's say, EC2 instance in AWS. Okay, so for that I'll just go and create call a resource. We call it name is resource, and what I name, so it is a AWS instance. So we call it a AWS instance, right? So AWS instance, and you have to give this logical name of the, let's say, instance is my EC2. Okay, I have created an instance called AWS instance, and the name of that instance is my EC2. And for creating any AWS instance, what do you need? You need your AMI. Okay, what is my AMI, right? So I need to give my AMI name. So if you log in your AWS instance, there also you can see what are different types of your AMI. I mean, AMI is nothing but which operating system that he wants to create, right? So Amazon Linux also has an operating system. You have Ubuntu, you have CentOS, RHL, Windows. There are many operating systems that are there. And each and every operating system has a different AMI. AMI is nothing but an image name, right? So then once you give the AMI name, then you give what are the instance type. So I'll tell about what is the instance type. So basically you give your instance type as T2 micro. Basically T2 micro is nothing but your size of your instance, then how many CPUs, how many memory, all that networking storage and all that, it talks about that one. So T2 micro is in the free one. So I'm just utilizing the T2 micro. Then what you need to do? You have to give a key name. I'll talk about the key name. Basically, when you give, you connect it to your AWS, right? To your, first of all, you have given your credentials, secret and tokens and secrets. Also, secondly, you have to provide your the system that from which I am trying to connect. Okay, that system itself should have a handshake between AWS and your system. For that, you have to provide a key pair solution, which is the, I mean, let's say you connect from one Ubuntu system to another Ubuntu system, right? So there you need to have a PEM file or a private key and all that. That private key and all that we need to provide, and that private key you need to download it from your you need to download it from your AWS account, and you need to keep it here. For the time being, I just given a name of my, let's say, Terraform. I'll show you how to do that, but first let me write it here, webinar. Okay, Terraform webinar, and then I'll give a name. This is for tagging stuff, or the name of your instance, which is nothing but name equal, let's say, master. Okay, this is all you need. Okay, this is all that you need. So I have my Terraform file is created. So Terraform has certain commands that you need to do first. So it is first initializing your Terraform. Okay, basically initializing means it will take all the Terraform versions and all that, and will create all the dependencies files and all that. So it is initializing your Terraform. So now look, so the initialize has been completed with ASIC of AWS to this one. So it will basically download all your providers and all the details to here. So now so once you actually do it, you can see there is a certain folder gets created, right? So which is nothing but your .terraform file, terraform folder, and there are providers and registry, everything will be here, right? So you will have all this. Then once your Terraform init is there, you can run your plan. So plan is nothing but it's a kind of a dry run. Before running your Terraform, you need to have dry run where you can see what are the things that it will go and create it. So we found an error here. What is saying with provider this maintain line one, the in provider this one provide something error is there. So let's go and see it. Okay, so what is saying, line number one, okay, provider AWS profile I have defined. Can anybody identify provider? Spelling is there. Means it. Nope. Compare Terraform validate and provide a credential, retrieving caller identity from STS, operation error, STS gate caller identity. No, that we have given, no? That inside the profile we have provided it. It is within, but was not. Did we provide a wrong? 1 second. US East one, right? Did I give the wrong region name? Yeah. 1 second. Just a second. If you'll try it, if it didn't work, then the path of credential, that is fine, but it is not giving it there. Okay, let me first path of credential, that also rectify it. So path of credential, what I'll do. So my path of the credential is located at, so I'll do an SCP minus R, where it is located. So it is located as Terraform webinar. Then I have root. What is my IP? IP is this one. Yes. Okay, so now log into this one. I'm logged in. So I think it will be copied here. Yes. Move from this one to root. Then I have Terraform, right? So we have everything here. So Terraform, I don't think it will solve. No, it won't solve. It is providing the line of provide Terraform. Okay. Yes. So basically, this is the code. I mean, I'll correct it and send it to the whole group. This one, if anything such is there. Um, so this is about what you need to do. Okay, your main.tf file, and once you execute this one main.tf file, so you have a plan, and then you have a Terraform, then apply. Okay, so if you execute the apply, it will apply. I think apply also will not work here, because plan is, if it's giving error, apply also will give error. And then once you applied, then you can do Terraform destroy. If you want to destroy your infrastructure, there are total 4 commands: Terraform init, Terraform plan, Terraform apply, and Terraform destroy. So basically, you need to initialize all your providers and all that. It's something looks like happened on the provider itself. I think let me just give a last try. Just a last try. No, it didn't solve. I'll check it out and I'll send you all the details. So basically, this is what region, I think we already have given. I don't think region will solve it, but I don't think it's underscore. It's region. But why didn't take from the profile itself? No, profile it should take. It's a bit strange that it didn't take from the profile, because in the profile we have provided the region, so it should be able to take it. But anyway, so it is creating the plan, and then from the plan you can actually go and once it will create, you can destroy. So let's go back, because we are already almost on time. Let's go back to our PPT. So what is things here? This is all about our webinar today. And next week onwards on 25th, we are starting a class on Docker, Kubernetes, and Terraform. So we are starting in the demo class on 25th, and 26th onwards on the regular class we are starting on. So that's about the whole webinar and the class that we are starting on. Thank you very much for your patience, for your time, and thank you very much. And now we can, if you have any question and answer, I mean questions, then I'm happy to take that. Part of AWS or can be used by other ways. Terraform part of, no, Terraform you can utilize for any, it's not only for AWS. You can, AWS is just a provider. You can have as many as providers. As I told, it has around 2,900 providers. So it can be integrated with anyone. It's not only about AWS. How to register for that class? I think you can check with the person who has arranged this webinar. You can check with them for that classes, and then you can register. Yeah. So can you create template from an existing setup which was created manually and then create the similar setup in another? Yes. So we set up, I mean, if it's installation anyway, it's a script, right? You can do it. And for this main.tf file, again, this is a script, this is the instruction that you are writing. You have to just write once and you have to utilize everywhere. That's where Terraform modular and all those stuff comes in. How do you create a module in Terraform? How, if you have 100 modules, how do you aggregate those modules? Those are the advanced part of Terraform. Then what is the exact difference between Kubernetes versus Terraform? See, Kubernetes and Terraform totally two different things. Kubernetes is just an orchestrator for your container. Terraform is a provisioner. It provision your infrastructure. Kubernetes doesn't provision your infrastructure. They're two all together. It's a kind of an apple and an orange. Two different things. Do you have a sandbox environment for practice? Actually, you can, if you have an AWS account, you can create it. You can create a VM and you can install in there. That can be your sandbox. Yeah. The Terraform has a UI application or it's only used in command. See, Terraform doesn't have any UI. Okay. Basically, see, at the end of the day, you have to install your Terraform. That is, it hardly takes some seconds. And then you write your program or you write your configuration, a story in a GitHub or GitLab or a Bitbucket, and then execute your Terraform plan. I mean, if you want to build an UI also, you can build it just to execute the, you have 4 commands you have to deal with in the whole Terraform. Init also, you don't need to use always. Init is once. Plan, apply, destroy. There are 3 commands. So you don't need any UI for it. Can Terraform use for ESXi and KVM VM deployment? Yes. Terraform can be used for ESXi as long as ESXi provides you APIs to call or create their compute. Okay. Can Terraform be integrated with the GitLab? Where is the state will be stored in case it is triggered from GitLab? Yes. Terraform can be integrated with the GitLab. Yes. GitLab is a GitOps tool. So they have a provision for Terraform, GitLab. So you can do that. And I don't think you need to install Terraform inside the GitLab. That is comes in build. You don't need to do that. Terraform, from difference between Terraform and Ansible, very good question. See, look, when Terraform and Ansible being built, both were open source. Ansible, particular Ansible is open source, but now Ansible is bought by Red Hat. So both job was different initially. Terraform just used to create for provisioning. It create the infrastructure. Ansible used to configure your infrastructure. Let's say I have created a VM. I have created Ubuntu 22 version VM. That's a job of a Terraform to create a VM, right? You have a compute. I mean, you have a storage, you have a OS, you have, you have a OS, you have a CPU, you have a RAM, you have a storage. By using all these hardware, you can create a system or a infrastructure. Now, to configure that infrastructure, let's say on that infrastructure, I want to configure Apache, I want to configure Java, I want to configure Python, I want to change few stuffs and all that. That is the configuration change. That is called configuration management system, right? That task is being done by primarily Ansible. Ansible used to do that, right? Currently also Ansible does that one. So basically what happens, Ansible takes care of configuration management part, Terraform is to take care of a provisioning part. Two different tasks. But later on what happened of late, Terraform also can do few of the provisioning, I'm sorry, few of the configuration. Once you create your VM, you can also install Apache and all that, right? Same case, Ansible also tries to go into the provisioning part, right? It can also try, it also tries to provision, but Ansible doesn't have this much of providers. Okay, as I said, AWS, Google, and all that, 2,900 providers and all that, right? That is not available in case of Ansible. So better use Ansible for configuration management, Terraform for infrastructure provisioning. The next, I think Asina asked, Packer can do the job of for Ansible for configuration. Yes, Packer also can do that. Yes, Packer can do that, but Packer has a certain limit. So look, Packer mostly OS configuration and all that too. All that it does. But just imagine in the case of I have 1,000 different servers available. I want to go and configure the same let's say Apache and all that on all 1,000 servers. I want to configure that one. That way, Ansible is much better than Packer and all that. And also your idempotent, which is called your if I have Apache installed and I am again trying to install, you cannot do that in packet, but it's taken care by your Ansible. Terraform cloud formation, which is better and why? See, again, this is a very interesting question. You go to any of the interview, they'll ask what is the difference in Terraform cloud formation. See, look, cloud formation, it is specific to your AWS, right? If I have written a cloud formation template that is called CFT, if I have written a CFT, it is only applicable for AWS. It won't run in Azure, it won't run in GCP and anywhere else, right? But if your infrastructure is only on AWS, and if you are 100% sure that in the next 20 years you are not going to change your infrastructure from AWS to any other cloud, then cloud formation you can utilize. But Terraform is a cloud agnostic. You can create a script, Terraform from script, okay, and you can run it multiple cloud as long as your providers, you change your script to a different provider. That's why you have a modular structure. You write a provider as a module, and depending on your cloud, you change your module. Okay. So can we manage snapshots of all the instances in a tenant and deploy to another replica tenant? Yeah, you can do that. So that's a very standard stuff, right? So yes, I would have liked people to ask if they are not muted. Okay, they are not muted. Let me see if I can enable someone. Okay. Rohit, we have the moderator. Can you allow people to speak? Okay. Yeah. If there is no question, then we are good. Or if anybody wants to ask question, they can still ask. See, Siri, look, Terraform Kubernetes, as I said, is a two. So you can only compare, let's say, Terraform and Ansible. That is a comparable objects, right? But Terraform, Kubernetes are not comparable stuff, right? I mean, there are they do two different things. Terraform is for provisioning, or if you can max, you can do configuration. Kubernetes is not for that. Kubernetes, again, it is for orchestrating your containers, right? You can create, create or deploy your application inside a Kubernetes, right? You can utilize Terraform to create a Kubernetes instance or Kubernetes cluster, but you cannot compare two, right? By using Terraform, you will able to create a Kubernetes. And Kubernetes, what it does, it orchestrates your containers. Let's say I have a container on which I have one application. I want to have multiple instances of those applications. I need to make the high availability of those applications, reliability of those applications, the DR of those applications, that will be taken care by Kubernetes. Those are very, very, very aligned towards your application specific, but Terraform is infrastructure specific. You can actually Terraform. You can do it by PyCharm. Also, you can do it. I think through VS Code also you can do that. VS Code tool, you can do it, and you have to add that plugin. I think even Eclipse, IntelliJ, all this tool also you can do that as long as you have those plugins are added. Yeah, that's what I said, Kiran. Any tool you can do it. VS Code, I have utilized VS Code a lot. Eclipse, which is my favorite tool. There also you add the plugin. VS Code will ask you to install when you write a TF file, it will give you a prompt to install Terraform plugin. And Eclipse, anyway, you can add these plugins. What is the help of using Terraform console? Console, that if you are asking about the console that I open, so that is not a console. I mean, see, I am a basically I'm not a UI person. I am a console person. I feel comfortable there because the advantage of it, you will remember your commands and all that. Secondly, debugging is much easier and all that. So, but it's all about liking. And you can anyway Terraform help and all that. You can identify all the command. Let's say, I hope I'm sharing. Yeah, I'm sharing it. So if I do just Terraform help, right, it will give me all the command and the details and all that. But UI, how do you get it, right? So if I'll Terraform init help, I think Terraform init, I think it should give me. Yeah, it will give me all the options that I have, right? So many, but you won't get it here, right? Okay, Terraform console. Yeah, Terraform. Okay, you are talking about Terraform console. So Terraform console, it will help you to write the code. Maybe it will syntax wise, it will help you. So that can, but I didn't use Terraform console itself. I didn't use Terraform console ever. I just write from here. Yes. But I wanted to have one, I mean, voice wise, I guess Vinod is there in the call.
Yes, certainly.
Can you unmute the people if anybody wants to ask the questions?
Yes, sir. I think we can unmute them, sir.
Okay. Yeah, so guys, if anybody wants to ask, unmute yourself and ask question. I would like to have, question to be asked, because I cannot, some of the question, I don't know what is your context, right? It will be better. Yeah, Narendra's question, how to store sensitive data in Terraform? You don't need to store sensitive data in Terraform, right? So basically, as I said, one of the use cases I said, right? You can inject your secrets into Terraform. Basically, you store your Terraform inside your vault, and from the vault you pull it and store in a Terraform. Basically, that will be a secret. That's how you store your sensitive. Particularly Terraform, we store credentials and all that, and those credentials will bring it from vault. Asika Terraform, AWS Terraform are same, right? No. AWS doesn't have a Terraform. AWS is cloud formation. So it does the same stuff, but AWS cloud formation is only specific to AWS, where Terraform can be used for any of the cloud. Okay. If no problem with this. So, yep. Thank you. If there is no question, I'll say thank you very much for joining. And if you are interested, then yeah, you can join our main class, which will be Kubernetes, Terraform, and Docker, which will be actually it will be a weekend class. And we have 8 weekend classes for all these 3. We'll go in details of Terraform, Docker, and Kubernetes. Yes. Thank you very much for your time.